18th International Physics Olympiad 1987 IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. There is a discount for group classes. Write me if interested. My email is fred1996@hotmail.com. Problem 1. Ascending moist air. Moist air is streaming adiabatically across a mountain range as indicated in the figure. Equal atmospheric pressures of 100 kilopascals are measured at meteorological stations M0 and M3 and a pressure of 70 kilopascals at station M2. The temperature of the air at M0 is 20 degrees Celsius. As the air is ascending, cloud formation sets in at 84.5 kilopascals. Consider a quantity of moist air ascending the mountain with a mass of 2,000 kilograms over each square meter. This moist air reaches the mountain ridge, station M2, after 1500 seconds. During that rise, an amount of 2.45 g of water per kilogram of air is precipitated as rain. Question 1. Determine temperature T1 at M1 where the cloud ceiling forms. Question 2. What is the height H1, at M1, above station M0 of the cloud ceiling assuming a linear decrease of atmospheric density? Question 3. What temperature T2 is measured at the ridge of the mountain range? Question 4. Determine the height of the water column, precipitation level, precipitated by the air, stream in 3 hours, assuming a homogeneous rainfall between points M1 and M2. Question 5. What temperature T3 is measured in the back of the mountain range at station M3? Discuss the state of the atmosphere at station M3 in comparison with that at station M0. Hints and data. The atmosphere is to be dealt with as an ideal gas. Influences of the water vapor on the specific heat capacity in the atmospheric density are to be neglected. The same applies to the temperature dependence of the specific latent heat of vaporization. The temperatures are to be determined to an accuracy of 1 Kelvin, the height of the cloud ceiling to an accuracy of 10 meters, and the precipitation level to an accuracy of 1 millimeter. Specific heat capacity of the atmosphere in the pertaining temperature range, Cp equals 1005 joule per kilogram per Kelvin. Atmospheric density for P0 and T0 at station M0 are ρ0 equals 1.189 kilograms per cubic meter. Specific latent heat of vaporization of the water within the volume of the cloud, Lv equals 2500 kilojoule per kilogram. Cp over Cv equals Chi equals 1.4 and G equals 9.81 meters per second square. Question 1. Determine temperature T1 at M1 where the cloud ceiling forms. Solution to question 1. Since the air moves adiabatically up the slope, we can apply Formula 1. Adiabatic dependence of temperature and pressure, which is converted to dependence 2 at points M0 and M1. The final answer is obtained from Formula 3. The temperature at point 1 of the cloud formation region is 279 Kelvin. This was the solution to question 1. Question 2. What is the height H1, at M1, above station M0 of the cloud ceiling assuming a linear decrease of atmospheric density? Solution to question 2. We believe that the density of the atmosphere depends linearly on the altitude. This means that the difference in pressure at points 0 and 1 is calculated based on the average value of the density of the atmosphere. That is, it is equal to ρ0 plus ρ1 divided by GH1. Formula 4. On the other hand, we have the formula for an ideal gas. Rho 0 by T0 divided by P0 is equal to Rho 1 by T1 divided by P1. Formula 5. From here we find Rho 1 from Formula 5. This density is equal to 1.070 kilograms per cubic meter. And using Formula 4, we get H1 is equal to 1,400 meters. This was the solution to question 2. Question 3. What temperature T2 is measured at the ridge of the mountain range? Solution to question 3. The temperature difference when the air is ascending from the cloud ceiling to the mountain ridge is caused by two processes, adiabatic cooling to temperature Tx and heating by delta T by condensation. As for the answer to question 1, we have formula 6, Tx equal 265 Kelvin. For each kilogram of air, the heat produced by condensation is LV multiplied by 2.45 gram, which is 6.125 kilojoule. From here we can find that delta T could be found from formula 7, which 6.1 Kelvin. Finally we have T2 equal 271 Kelvin. This was the solution to question 3. Question 4. Determine the height of the water column, precipitation level, precipitated by the air, stream in 3 hours, assuming a homogeneous rainfall between points M1 and M2. Solution to the fourth question. If 2.45 grams of water fell as rain from 1 kilogram of air in 1500 seconds, then from 2000 kilograms will fall 2.45 grams multiplied by 2000, which is 4.9 kilograms. And in 3 hours, 35.3 kilograms will fall on the surface of 1 square meter. Hence, the precipitation level will be equal to 35.3 kilograms divided by the density of 1000 kilograms per cubic meter and divided by the area of 1 square meter, which gives 0.035 meters or 35 millimeters. This was the solution to the fourth question. Question 5. What temperature T3 is measured in the back of the mountain range at station M3? Discuss the state of the atmosphere at station M3 in comparison with that at station M0. Solution to the question 5. Temperature T3 behind the mountain we can find from adiabatic heating to temperature T3, which is 300 Kelvin. The air has become warmer and drier. The temperature gain is caused by condensation of vapor. This was the solution to question 5. And here we finish discussion to problem 1.